Assalamualaikum and good evening. Can everyone hear me okay?
Okay, sir.
All right. Okay, so we'll continue our lecture to finish up investment appraisal up until the documentation required for energy management system, right? Okay, as per our last class, I have touched a little bit on the technical evaluation, which is to evaluate the total energy consumption for a specific usage. For in this case, lighting changes, where we'll take into account the technical spec of it by calculating the energy consumption and then compare it with the ringgit and cents value lah. So yeah, in the last slide, we've discussed that by converting a panda floor lamp, which is this one, the green and white panda floor lamp here, we change the bulb into the LED version, we will be able to save $7.10 running 24 hours in a month. Of course, that may not seem like much, but if we uh, calculate overall for the whole house, chances are you'll be installing more than one, at least three or four in a house. So that will amount to around RM 20 to 30 ringgit being saved from your monthly bills, which is quite significant in a month. Assuming running for 24 hours lah. So if you're running it less, then your bill will be less lah. Because ultimately, lighting is only around 30 to 40% of energy consumption for your house. The most of electrical energy being consumed is by refrigeration and also air conditioning. So yeah, if you're able to change your air condition to a much better air condition technology, or the fridge with a 5-star rating from our Malaysian approved labeling system tu, kita dah discuss chapter 1, chances are you'll be able to save a lot more lah in your electricity bill. But the gist of this slide shows is that by calculating the technical spec, which is the balance factor and the operational watt, you can calculate the actual saving that you can get from changing specific types of electrical component, electrical equipment in your house. Contohnya. Okay, bear in mind I had just just yesterday I had my booster vaccine shot. So today I'm a bit sleepy, a bit yeah. The side effect for me is, I guess, more or less like my second dose of vaccine. So my mind might a bit here and there, but I'll try my best to deliver the lecture. Okay, so next we'll look into the financial evaluation. Basically, we'll be looking into SPP, NPV, and IRR. The basic, most simple calculation will be the simple payback period. The second most easy, not to say easy lah, but most widely used is the net present value, provided you have all the data. And then the last one, which is also not that complicated, but it's for a specific certain period of time only. People will use internal rate of return. So these are the three things that you need to be aware of for you to calculate whether you have actually, okay, the main thing that you want to do this calculation is to know whether or not your venture into energy management program is viable. The investment that you've poured into the project of energy management is actually good, in the sense that you want to prove to your boss whether it's actually does deliver the cost saving that you promoted. And also it can help you to decide which component, which, what do you call that, which equipment that you could buy. Sorry, otak saya bayang. Mamai. Which equipment that you should buy from a list of suppliers that you got your quote from. So these are the things that you can use to evaluate the, the actual ringgit and cents in this in terms of energy management system implementation. Okay, that said, we'll be looking more into the interest rate, more into the saving cost. We'll look into more into total investment capital being spent and whatnot lah. So not so much on the equipment itself, not so much on the technical specification. I think most of you from business schools are quite familiar lah with some of the terms here compared to me. So I would think you will have no problem here in this calculation of financial valuation. So the first being, the first tools that we're going to look into is the simple payback period. Simple payback period is the most basic calculation. It's just the amount of investment being spent. Can you see my mouse? Oh, yeah, okay. The total amount that you're going to invest divided over potential annual saving that you could realize for that particular energy management steps that you want to take lah. So it is easy to calculate. It's just division. Expressed in simple term, does not require inflation or interest rate. So it's not complicated. It's just one ringgit divided over potential ringgit savings. So does not have to take into account the inflation, the discount rate, any kind of fees required for you to engage the investment, evaluate the investment. And then it is a quick method to compare projects. So let's say you have one or two project of energy management implementation that could be had in your company. So let's say you want to decide whether to pursue solar installation first, or change the the chiller room first, or maybe just the lighting first. So, and you have a certain a finite amount of funding. For example, you only have 100,000 instead of 100,000 1 million, because installing solar panel is quite pricey. You only have 1 million, so you want to decide which out of the three, which is the best to pursue. So these are the steps that you can do lah. So let's say you find out the annual saving achieved from solar panel is maybe 500,000, compared to what you call that, chiller installation and lighting is just maybe around 200 to 300,000. So most probably you'll be aiming for solar panel lah if you have 1 million. But let's say if you have 500 million, 500,000, 500 million, 500,000, and you decide that to acquire solar panel, you might have to make a loan and whatnot. So that might not be feasible. So you try to find the SPP, the simple payback period, or just the chiller and the lighting. So most probably you will be going to chiller lah, because chiller will reduce your electricity bill up to 50-60% compared to lighting, which is just merely 20 to 30%. So this is the types of evaluation that you could do, a simple evaluation to compare which project that you need to put forth first, depending on your target plan lah. Okay. However, the disadvantage here is that it ignores the difference in the amount of saving. So let's say when you're talking about energy saving, it's not just the electricity bills. It also the human resource, the saving cost due to inflation rate, and other types of savings that involves with energy management, because it's just compare RM versus RM. It does not take into account the interest rate, inflation rate, and whatever else involved with the savings amount, and also hiring people and whatnot, human resource capital. And then it ignores the value of saving after the payback period. That means if you only account until the annual saving, let's say you have achieved the 500,000 that you paid up, the paid up capital of 500,000. After that, SPP doesn't reflect whatever saving that you could get from the calculation. So it just until you paid up, the paid up capital is being paid. That's all. After you reimburse the capital, it will only reflect until you reimburse the capital. That's it. So any amount after that is it wouldn't be displayed here like SPP. And it also ignores the time value of money. That means sometimes money, if you accumulate it in certain account, can accrue maybe what you call that, not interest rate, dividend. So it does not take into account of that. It's just a simple calculation between which project would be able to yield the high saving. Not doesn't take into account time, doesn't take into account human capital or any other savings that could be obtained from the energy management system being implemented. So it's a simple payback period typically used to determine which project to pursue from henceforth. Okay, so let's say for example, you're trying to, maybe you have a limited budget, not so much, not to the extent of you able to change a chiller or even solar panel. So you might have only a certain amount of money or loan from certain business operation. So you decided to pursue to change the light bulb. So if you looked at the light bulb itself, the cost is around 1241, but including shipping and whatnot, we assume 15 RM. So we took it down to just one unit first because we want to see how much paid up capital, the capital can be paid up by for a certain amount. So as you can see here, it's 15 divided over, because we have calculated previously $7.10 amount of energy being able to be saved once you change the light bulb to LED. So we decided 710 is quite can be a benchmark. So we put there in our calculation 710 times 12 months. We found out that because this SPP should be in annual, so that's why it should be in 12 months, not 4 or 3 months. It should be 12 months annual. So it was found out using a simple SPP calculation that the capital can be paid up in around 2 months. So it's quite efficient. That means it's quite fast. If you spend 15 ringgit for the next 2 months, you'll be able to reap the rewards. Any kind of saving from the what do you call that? From the installation of the LED lamp can be considered as revenue to your company. Sorry, otak saya memang ni. Okay, and then so for SPP, a simple payback period, it only accounts to the amount of investment being paid. So any duration after that, on yearly basis ke monthly basis ke, they won't be reflected on the calculation. So you can see that after the paid up capital being paid, the saving account here most probably will be neglected. It won't be taken into the energy management committee punya ni lah. So what you can conclude here for SPP is only being conducted at the initial stage of the project. Once they have decided the project, what to pursue, then they will need to have more depth in detail calculation. And that's where, to diagnose the value, that's where the NPV and also the IRR comes in. Okay, depending on the availability of your discount factor data, R is the discount factor. If you don't have the data, or you need to find out the discount rate, so that NPV value will be better reflected on your company energy consumption. So it relies heavily on the discount rate. So we'll look into the elaboration first. NPV is a financial parameter, indicates the amount of that project will earn over its expected lifetime in today's value of money. In today's, so that means if you want to get a better reflection of energy saving in terms of to counter inflation rate and whatnot, you need to reiterate lah this calculation every single year. So each year you have to recalculate your NPV and then to get a better picture, because inflation rate we don't know how much per year. It's a continuous punya numbers. So you have to redo the calculation every single year. So the keyword here is in today's value. So that's why RNI you need to update every single year. Okay, net cash flow, inflow and outflow in each year into the project will be multiplied by the discount factor for that year. So discount factor means the price. It's not about the purchasing. The price will be cheaper, but because the saving has been realized, so the amount of money that you have to spend to buy that equipment will be lesser. So that is what it's meant by discount. Not that the price will be cheaper, because of course inflation rate, shipping, or oil prices increases and whatnot will contribute to the price being a little bit higher compared to previous year. But consider that you have achieved savings from your energy management implementation. So it's you can consider that the next purchase of the energy equipment will be subsidized by the saving that you have got from your electricity bill. So that is why the discount factor needs to also take into account the what do you call that, the inflation rate for that year, because money today will not have the same value as money in 1 year's time. I think most of you business guys understand this concept, because if I'm talking to engineering student, most probably they will not be able to see this. They argue with me, but this the if you reflect on the 2 years time, back then a single house is 250,000 in 2008 2010. Now the same house will cost around 750,000 in 2021. And after the pandemic, it seems almost every, if you watch the news, almost every item is increasing in prices. Somehow everybody's, all the suppliers, all the pembekal semua dah naik tanduk. Semua nak bagi apa ni lah, harga mahal lah lately. Sayur pun mahal, ayam pun mahal. So, and there is a news that what you call that? The building supply items has also all the steels, all the cements, and the batu-batu and whatnot. They plan to increase the price. So I would think in 2 or 3 years time, harga rumah akan naik balik, akan naik lagi. It has been saturated for the past few years, but after this is, I'm not saying that orang ni jahat, orang jahat. No, this is actually very normal. At the end of every pandemic, at the end of every economic downturn, price will go up. I don't know the logic behind it. I'm not an economic professor, but studies and historical data has shown that that will be the main thing you guys will be facing lah. I myself pun kena face juga, sebab but I myself dah ada 3 rumah dah pun, tak gaduh lah. You guys lah nak kerja nanti, most probably nak beli rumah pun susah sikit, but that you have to take into account that for that thing, because it is a real thing. It is currently going. So that said, discount factor here, you have in energy management program, you have to consider inflation rate, especially nowadays, where almost all the items are gaining in prices. So I would imagine once you're working and you've been appointed as energy manager, the same solar panel that I bought for UiTM Terengganu solar project will have an increase in price when you are doing it later on, when you want to propose the energy management program later on in your company. Okay, so that's why this calculation has to take account where R is the discount rate, the inflation rate and whatnot, and you have to include the discount factor. Discount factor here is very important. You have to really get this formula jot down, because it will be used extensively in calculation of NPV and also in IRR. here. This is the discount rate. This is the same discount rate. Okay, so we look into the NPV. We've discussed this. Okay, so NPV, how to calculate it is basically for that year. For from the start of the sorry, the net cash flow times the discount factor for from the start of the project until the year that you're calculating, for each year until the year that you're calculating. Let's say you started your energy management program in 2020. So that year's net cash flow times the discount factor you have calculated for that 2020, and then you multiply it, you plus with the 2021 net cash flow, multiply with discount factor, and then you subtract total investment that you have spent. So that is actually the net present value you got from for that year from start 2020 to 2021. That's how you get your NPV value. I believe so far I've one, because this is more in the implementation, so we don't have a case study to show NPV. But I'll try to discuss with my colleague if we have a case study that we can show it to you to better understand how to calculate NPV. But don't have to worry, because there's two. Typically, they wouldn't ask you to calculate NPV, but more on the theoretical parts lah. Because calculating NPV, it's more on specific cases. If you don't have the data, most probably you won't be able to calculate the NPV lah. But this is included here for you to know what is actually being done to evaluate any. I mean, there's a formula lah for you to have to calculate in order for you to come out with the best proposal for your client. Should you become energy manager lah later down the road. So this is the calculation that you need to do. But for your test, for your syllabus, most probably won't be asked this one. It's a bit more focused down, whereby it's not going to suit you in your syllabus. But it's good to know. Okay, so the advantages of having NPV is that it takes into account the savings that you have accumulated for each year, and then it takes inflation into account due to the discount factor, Rumo's discount factor being here. It take the project lifetime into account. I mean, each year ni, so project lifetime tu kita boleh tahu lah. This year, second year, maybe dah tak boleh pakai panda floor tu, dah tukar yang lain pula, dah rosak ke. So each year kita tahu lah. However, the disadvantage here is that it's more complicated to calculate, because you need to get information on R and also N, the number of years, which is if you're just coming in, you need to know lah. You need to study the organization energy management program quite a bit. And R, you need to refer to your financial all the purchasing inflation rate and whatnot, compared with previous data. So it's going to be a bit more hassle lah. You need to have more information and decision on the discount rate. So the keyword here, the higher the NPV, that means your energy efficiency project is good. So that means as the years goes by, you need to make sure that the amount here, the discount factor and the net cash flow for that particular year is hugely, something big minus something small will be giving you a huge number, right? So you need to make sure at this area here needs to be a much bigger numbers than years before. So in order for you to realize a higher NPV value. Again, NPV value needs to be high to show that the energy efficiency project has successfully been implemented. Okay. So most organizations use NPV to select the most economically attractive project. Some organizations, however, have no particular, because determining the discount rate isn't actually easy. Right to the point, you need to discuss with your financial team, your account department, with the buyer, the seller, also with the bank, because any kind of your money RM is actually dependent on the If you want to purchase a loan get a loan pun, you have to refer to the interest rate set by the BNM and the organization that you want to loan with. So it might be a bit more difficult. So therefore, the other alternative is for you to approach internal rate of return, IRR. This is much simpler, where the discount rate for the NPV, we set it at 0. So that means there's no saving. There's no previous year's punya saving. That means every single thing you buy from a fresh, duit baru lah. Maksudnya, you tak pakai duit saving your electricity bill tu, you memang totally beli baru. Tak payah discount. So we set it at 0. So IRR can be compared with current interest rate for borrowing money. So you still can take into account the interest rate. It's just that this time around, you're not using your savings that you got from your electricity bill. So in order for us to conduct internal rate of return, slow sikit. The discount rate, which is this one, we set the discount rate at NPV equals to 0. So NPV ni yang awal kita kira tadi, NPV, we set it as 0. So now total investment, we can bring it to the other side. So total investment will equal to the same formula lah. The only difference is that NPV ni we set it as 0 for IRR. So that we can take into account the internal rate or the interest rate only. So as you can see, the same formula, net cash flow multiply with discount rate. However, instead of the subtract the total investment that you have spent on the first time you implement a project, now the total investment we calculate the total investment based on the amount of energy being saved or being spent for that energy management program for that year. So it's easy to compare because once you got the first year, you'll be able to see the total investment being spent the next year and the previous years and the 2 years after that. So it's easy to compare the interest rate for each year. And it takes into account the time of value of money because there's the information of interest rate as compared to SPP that we calculated earlier. And this the problem here is that since it's not calculated under NPV, we will be having a lot of multiple figures. So cash flow change direction more than once, so it's quite difficult for us to pinpoint which money does it come from, or where the money comes from for each year, because kita tak separatekan total investment. So each year the total investment dia berbeza. As the years goes by, total investment will be either increase or decrease. So it's quite hard for you to find out where the source of the money comes from. It's not because we want to detect hanky-panky. No, it's more on to detect where does the money come from, the energy saving that we got, or it totally come from sales on revenue of the company itself, which is not good for a business owner. So the higher the IRR, the better the energy efficiency project. So the same, if the IRR is high, then the energy efficiency project will be deemed successful. Okay, so when we are talking about, this is financial evaluation. So let's say you have calculated all the IRR, MPV, SPP, and you decided to pursue this project. So you might want to secure your financing either internally, which is from internal budget from the internal budget shareholders or the owner of the organization, or if the business is cash strapped, that means I think you guys business collector not about me, but if the operation is really not the extra money lying around, you might want to secure and look at external funding. And there are two ways for this. One is ESCO, internal being done in domestically punya environment, or clean development mechanism where it is a more international based punya program. This is from UNESCO, and this is just privateers, ESCO, Energy Saving Company, ESCO. So if you're approaching ESCO, that means all the source of fund, all the supply is being handled by ESCO. They will get this fund for you, They will install, they will implement, they will record everything for you, and any kind of energy cost savings will be given to them. That means your electricity bill, you are still paying 500,000 for, let's say like you're paying 500,000 a month. So even with the installation of solar panel for the next 5 years, you still have to pay 500,000 per month. But once the agreement ended, because you sign a contract with the ESCO, and then all the energy cost saving will be given to you. That means you won't have to pay extra 500,000, the 500,000. So most probably all the energy saving realized from the implementation now can be given directly. You can get it directly from the electricity bill. That means you're paying electricity bill lesser only then, because dah pakai duit dia kan, dia pun nak lah reimburse balik duit dia and also sama untung. Kau takkan nak buat kerja free je. Okay, private company. Okay, so then we look into CDM. Okay, CDM is a bit more international, so that means it's going to be a bit harder for you to secure, because you need to find industrialized countries yang available to sponsor your purchase, your whatever energy management program that you want to implement. So it is one of the two project-based flexible mechanism of the Kyoto Protocol. Ingat everything yang Kyoto Protocol, Kyoto Protocol ni bukan ban, it's actually a meeting of government that has decided to pursue green energy punya technology to enforce green energy implementation lah in the whole world. And it's done in Kyoto, so you can just Google Kyoto Protocol. There's a lot of interesting things that you can read here due to the nature of politics. I mean, you keep on seeing US kata they want other countries to become more green, tapi they are the one who vetoed Kyoto Protocol. They are the one who won't commit to all these proposals being implemented here in Kyoto Protocol. So it shows how hypocrite US ni. So it's a good ni juga lah to baca. The mechanism are designed to make it easier for the industrialized country. We are the developing country, and all the Japan, Korea, South Korea semua tu is industrial country, because they, let's say lah, for example, they have met already with their GHG emission commitment that they have made in Kyoto Protocol. So now they want to pursue further nak aktifkan lagi green energy adoption ni. So instead of doing it at their own country, because they have already achieved the target, so they want to venture out. Of course, being able to venture out ni pun dapat duit juga. It's incentive juga. You have macam ESCO tadi, that means they install it to the other country and they can get the savings money from them lah. So the same thing goes here. So let's say their country themselves has successfully reached their own target, so they want to venture out. So they might want to go to Malaysia, for example, to help us achieve our target. So CDM is mandated in Kyoto Protocol to assist developing countries in achieving sustainable development. So how it works is that industrialized country, German, for example, let's say they have achieved their target and they want to get some money and of course help other countries to achieve reduction in gas emission. So let's say they come to Malaysia with the ESCO approach tadi lah. That means they install everything and energy savings as per contract tu they will gain their capital and some untung from that contract, and after a period of time, then only the countries will be able to enjoy the energy saving that they have done. Of course, it seems like macam tak fair, tapi it's actually good because these developed countries can also have technological transfer, experience in energy management, because if not then like macam company kecil tak ada duit, so sampai bila-bila dah tak siap, tak akan buat energy management program kan. So having this CDM mechanism allows for the developed countries to realize it and also build a rapport with other company and other companies from other countries, which may or may not open up a new business or opportunities. Who knows, right? So CDM is a good approach that you can get, but it's a bit more harder to find, especially nowadays, given that due to pandemic and whatnot, most international restriction is being enforced. So that said, if you want to implement this in a year or two, chances are it's quite hard. However, there is this mechanism. If one day, let's say 3 years or 2 years down the road, open balik, everything goes back to normal, then this is the option that you guys can try to approach if you want to implement energy management program in your company. So okay, they don't just claim credits. They can also actually get the savings under contract lah. Of course, money moves the world. So buat baik pun somebody will get paid. So under this CDM, because okay, if you look here, it claims credit for the emission that the project achieves. That means emission reduction in emission that the project achieves, and use this credit to meet the target. So let's say they have their target, tapi dia tak ada their own country dah penuh, dah achieve their KPI, so they move to developing countries. So any amount of energy saving, because you have to understand, it's not fair for them, German, to come to Malaysia and then claim that it will not be attractive lah sebab kita punya RM rendah. So if we manage to save even 100% of the energy being consumed pun, but if you're talking about ringgit and cents, it won't be attractive for German to be able to claim that they have been able to save the company in Malaysia around RM 1 million per year. To them, our money is really rendah sebab inflation mata wang tu. So in order to be fair, the CDM mechanism propose this conversion factor lah. So in terms of looking at ringgit and cents, we looked into the energy amount. So 1 megawatt hours is actually equals to 0.55 ton of CO2. So let's say you're able to reduce energy consumption for that country, the German, and able to save. Able to save around 1 megawatt hour of energy for that company. That means they are able to reduce 0.55 ton of CO2 for their country, for Germany. So that's the conversion rate, because if you can't use ringgit and cents, you can't use because of the mata wang punya perbezaan tu. So they have to use the ton of CO2 lah as the conversion unit in terms of energy. So and also some countries not using unit yang sama. So bunker oil maybe diorang pakai gallon, kita matrix pakai liter, for example. So it's, to be fair, we will be using a ton of CO2 because CO2 is the emission everyone is trying to reduce. Okay. So and then ultimately 1 ton of CO2, if you're able to save 1 ton of CO2, basically you're saving 10 in terms of ringgit and cents, where everyone agrees to use US dollars as the main currency to compare. So CO2 is under CDM is being mandated at 10 USD. So it's not really that attractive. Nampak macam nak dapatkan 1 ton punya susah, tapi dapat 10 USD. But actually it's not about the money and cents, it's about the target, this energy saving target that each country has committed to reduce. Okay, so this is another way to contribute to the reduction of harmful chemical gases, GHGs. The organization can consider this mechanism as one channel to get external funding, like I said. However, nowadays it's going to be a bit harder, but any information can be referred to this website, which is United Nations FCCCC. I'm not sure what this FCCC is, but these are the website that accommodated CDM. So that means if let's say a company, an organization are agreeing to reduce energy management, to use energy management, implement energy management, you might want to look into this website to help you secure financing for your project. Okay, then we look into, okay, we have finished talking about investment valuation and investment appraisal. So now we look into the human resource needed to achieve our energy management program in the system. So before you start everything, you need to collect information first. The total number of staff in your company, the educational background, and the job description, because this information is going to be used for you to set up your energy management system. So this information is critical to get to know your company capability. And then once you have got the information, now you analyze the collected information and group each, because we are talking about human capital. We're not talking about the machine, we're not talking about the electrical energy, we are talking about human. So once you got that information, now you can divide it over two groups: non-energy controlling staff and energy controlling staff. So as the name suggests, non-energy controlling staff typically like your cleaner, your operator, your cleaner, your window washer, or maybe a support staff lah. Whereby energy controlling staff is the one that has direct control over the operation of the equipment that may consume your electrical energy. So you can divide it into two. Even your boss pun sebenarnya is actually non-energy controlling staff, but because they are the owner, so typically they need to be in the energy committee lah, but they are not the energy controlling staff. Okay, so once you have decided who belongs to which group, then you can start to tailor-make training or awareness program suited for each of the group component. So for non-energy controlling staff, they only need to be aware of energy management implementation being implemented in your organization. They only need to be aware. That means you only put posters, you need to ask them their signature in the documents, but other than that, that's it. They don't have to participate. They only need to be aware, and if let's say they observe some energy wastage being done, they should be able, they should have some sort of kuasa lah untuk tegur, untuk do something, let's say turn off the fan ke, or advise the person to reduce it ke, amount of energy, however practical for that event. And energy control staff can be the management, can be energy efficiency pro staff, and also the operator. So the main critical person here, as you can see here, is the energy efficiency staff. This one can be the head of area of the machine, can be the manager, can be the operator. So they need to know everything. They need to be aware. They need to what you call EM ni? And they have to participate in the energy management training, and they need to be included in the training of the technical side of things, because they are the one who actually do the job. Management, they only need to know about the energy management being implemented, and also the energy management training processes. So they don't have to touch the machine themselves, so they don't need to know on the technical side of it. And the operator, they need to be aware that we are implementing energy management program. They don't have to know the energy management training process, because they only do it. They don't have to report to anybody. But since they are doing it, they need the technical training to efficiently operate the machine, to realize succinct energy saving steps. Okay, awareness training is the one where almost all would need to know, even though they are non-energy controlling staff, your cleaner pun, they need to know and they need to be aware of energy management steps that we are taking. So it's to raise the staff awareness. Energy management training is more on the energy management program itself. Who to report to, what kind of report you need to do, what kind of EM work need to be done. The documentation that we've discussed just a few slides back, last 2 weeks. So these are the training involved in the for the for the what you call that management for the energy efficiency stuff. So and also the management. So they need to know the process from top to bottom so that they are able to guide and also get the proper reporting being implementation of energy management in the organization. And technical training, as the name suggests, is more on those who have direct influence over the machine operation themselves. So basically to train the technical staff on the technology and technique to improve energy efficiency in operating a machinery, for example. And then we look into the documentation. Now this is going to be almost the end of the slide. So in the documentation, basically it must provide clear working guidelines to all level of staff. So jangan guna bahasa lawyers. Saya biasa baca TNC ni di rumah. Typically benda yang senang dia punya ayat tu apa bersepah-sepah, so lebih pening. So working guidelines, jangan guna ayat macam tu. Please use as simple words as possible so that all level of staff, even your cleaner, will be able to understand that. Provide recommended working formats to energy efficiency staff so that energy management program tu berjalan smoothly, so that everyone knows who to report to, what kind of report they want is being expected from them, what to audit and whatnot. And it's also the documentation needs to be also provide official working evidence for auditing process, so that the data that you have collected is actually directly reflected on the machinery themselves. So there are 3 types of documentation: working procedure, working manuals and tools, and monitoring documents. So type A, working procedures, all these documents actually has been discussed in the previous slide last 2 weeks. So for working procedures, more on the energy management side of things. So as you can see, developed by Energy Management Committee, and the user is the organization themselves, application in the whole organization. And working procedures is not to say the machine themselves, but the whole area in terms of energy management architecture, not so much on operating the machinery. Whereby working manuals and tools is more on the machinery, on how to operate the machinery, on how to log the data, on how to calculate the energy consumption themselves. So this is more specific towards the machine and the area that you have defined as EAC. And whereby monitoring document is more on auditing. So who prepared it, who to report, or who does the report be submitted to, everything is being listed here. So I don't want to go one by one because it's actually just a repetition, except that who to report, who make it. So it's kind of direct now, so you can just read it for yourselves. And to review the process for type A, should be done by energy manager. And finally, once it has been reviewed and accordingly energy manager has accordingly found it to be proper, then it will be approved by the energy management committee. Working manuals and tools, since it's specifically for that machine or for that area that has been defined, so it is being reviewed by the head of EAC, and again approved is also by energy management committee. Maknanya top management yang tahulah, sebab energy management committee ada top management kan. And then monitoring document done by energy manager and approved by again energy management committee. Top management kena approve. So as you can see here, every single thing is being approved by the energy management committee. So that is all for today. Any question? I think it is a more technical side of things in this slide. So you might want to digest it. But again, if you have any question, you can ask me while I'm here, or if not, in the WhatsApp. Nantilah WhatsApp punya. Okay, so before I end the session today, I think that we ended quite early. So do you have any question before I end the session? Oh, semua orang giling, bagus. Dari pemamai ni. Okay,